Calculating the pH of a buffer. So I think it's important to look at a buffer that is a solution of a weak base with its conjugate acid, because sometimes you have to think a little bit carefully about these. So methylamine is our weak base, okay? So a weak base will accept a proton from our water. So if it's accepted a base, that'll be CH3NH3, and of course it's also gained a +1 charge for the proton as well as a hydrogen. So that would be our conjugate acid plus OH minus. Oh, okay, there we go. So that is our base dissociation reaction. I guess I should put in my nice little arrows in there. And you can see from the salt, we got methyl ammonium bromide, CH3. Oh, wrong HC8. Come here, you. CH3 NH3Br. So, of course, if that is a salt and it's soluble, it's going to break apart into a cation and an anion. So the cation is going to be everything that's not that bromide ion. I know you guys may not be in so much practice of spotting these for acidic salts. So this would be an acidic salt because the cation component is the conjugate acid of a weak base, in this case, methylamine, right? And then the Br minus is our anion, and that's a neutral anion because it is the conjugate base of a strong acid, which would be hydrobromic acid. Okay, so this is my conjugate acid of my weak base. So the base is the methylamine, so that is the 0.60. That is our base. That is our conjugate acid. So we want to know the concentration of the methyl ammonium ion coming from the ionization of the salt. So as you can see, there's a 1-to-1 molar ratio. For every 1 mole of methyl ammonium bromide that dissociates, is going to yield 1 mole of my conjugate acid, my methyl ammonium ion. So in terms of concentration, it's going to be the same. If I got a 1.3 molar solution in methyl ammonium bromide, that is going to yield a 1.3 molar solution of methyl ammonium cation. So that is my acid component. I'm just going to scooch that along this side so we don't get confused. So Henderson-Hasselbalch equation is pH equals pKa. It's always pKa plus log the concentration of the base over the concentration of the acid. So my base is going to be my methylamine, my acid is going to be my methyl ammonium cation, and I am going to need pKa for that cation. I just realized I've written equals here. I'm going to just put a big plus over it if I can do that. Do I have a big plus? No, I'm going to draw my own big plus. Okay. Big plus. This is a big plus. Sorry. That's typing and talking. So I have to calculate pKa. I have to calculate pKa for my methyl ammonium cation. So this is where people sometimes get confused. I've only been given Kb. Kb is for my methylamine. So luckily we know all these relationships, right? And a really useful one is pKw equals pKa plus pKb, which is exactly equal to 14. You could also use Kw equals Ka times Kb equals 1 times 10 to the minus 14. If you've learned how to do it that way and you're happy doing it that way, it's the same thing. But of course, then you're going to have to convert Ka to pKa. So then you're going to have to do the minus log, right? So pKa equals minus log Ka. So just make sure you're aware of that, right? So that's an alternative way to do that. So I'm just going to put both of those in parentheses, okay? So in that case, all we have to do is convert Kb to pKb. So pKb is minus log of Kb. So again, don't get confused like that you're like halfway through this and you're not finished. So minus log of 4.4 times 10 to the power of minus 4. What number are you? You are going to come out to be about 3.3 and change, 3.35. So that's enough decimal places. Okay, so now I can calculate my pKa for my methyl ammonium cation. That is going to be pKw, which we know is always 14 minus pKb. So 14 minus 3.3 It's going to be a value of pKa of 10.6435. That'll do. And it's basic pKa, right? Remember, pKa is going to be approximately equal to pH for a buffer solution, for the buffer capacity. So that makes sense because it's a base buffer. Okay, so now we can just substitute into our Henderson-Hasselbalch equation. So pH is the pKa, so that's going to be 10.6435 plus log of the concentration of the base, and the concentration of the base is our 0.60 over the concentration of the conjugate acid. So that is going to be that 1.3 it was, okay, and stick that in your calculator. You should get a number, and that comes out as being TH of is this working? I hit the wrong button, so I'm confused. We should be recording. Okay. Whoopsie. So my pH should come out to be 10.31 to 2 decimal places. Oh my gosh, I wonder how long I was paused for there. It didn't flash at me like it usually did. Okay, so hopefully that is very helpful for calculating pH of buffer solutions.